Understanding the key properties of complex systems can help us clarify and deal with many new and existing global challenges. From pandemics to poverty, a recent study in Nature Physics found transition to orderly states such as cooling in fish, all fish swimming in the same direction, can be caused paradoxically by randomness or noise feeding back on itself. That is a misalignment. Among the fish causes further misalignment, eventually inducing a transition to schooling. Most of us wouldn't guess that noise can produce predictable behavior. The result invites us to consider how technologies such as contact tracing apps, although informing us locally, might negatively impact our collective movement. If each of us changes our behavior to avoid the infected, we might generate a collective pattern we had aimed to avoid. Higher levels of interaction between the infected and susceptible, or higher levels of interactions among the asymptomatic. Complex systems also suffer from a special vulnerability to events that don't follow a normal distribution or bell curve. When events are distributed normally, most outcomes are familiar or don't seem particularly striking. Height is a good example. It's pretty unusual for a man to be over 7 feet tall. Most adults are between 5 and 6 feet. There is no known person over 9 feet tall, but in collective settings where contagious shapes behavior, a run on a bank, a scramble to buy toilet paper, the profitability distribution for possible events are often heavy tailed. There is a much higher probability of extreme events such as stock market crash or a massive surge in infections. These events are still unlikely, but they occur more frequently and are larger than would be expected in a normal distribution. What's more, once a rare but usually significant tail event takes place, this raises the probability of further tail events. We might call them second order tail events. They include stock market gyrations after a big fall and earthquake after shocks. The initial probability of second order tail event is so tiny, it's almost impossible to calculate. But once a first order tail event occurs, the rule changes and the probability of a second order tail event increases. The dynamics of a tail events are complicated by the fact that they result from cascades of other unlikely events. When COVID 19 first struck, the stock market suffered stunning losses, followed by an equally stunning recovery. Some of these are dynamics are potentially attributable to former sports better, with no sports to bet on, entering the market as speculators rather than investors. The arrival of these new players might have increased inefficiencies and allowed savvy long term investors to gain an edge over bettors with different goals. One reason a first order tail event can induce further tail event is that it changes the perceived cost of our action and changes the rule that we play by. This game change is an example of another complex system concept, non-stationarity. A second canonical example of non-stationarity is an adaptation, as illustrated by the arms race involved in the co-evolution of host and parasites, in which each has to run faster just to keep up with the novel solution. The other one presents as they battle it out in an evolutionary time.